Okay, so we recently were talking about absolute value functions. And there's a secret thing happening in absolute value functions, and they are called piecewise functions. Now, piecewise functions are kind of exactly what they sound like. They are functions that are in pieces. Okay, so let's look at what we've been doing that we didn't even know we were doing. I love it when that happens. Okay, so let's look at a graph. And let's say that we have been working with y equals the absolute value of x plus 5. So if that's the case, then we know that we've got a function that's doing this. Let's see how amazing my graph can be today. Okay, so this is a graph of the absolute value of x plus 5. When we talk about piecewise, when we talk about a piecewise function, it means we're going to break it into pieces. We're going to break this into the left side piece. And in this case, let's make that green. So there's our left side. And then our right side, I'm going to make that red. But you could see I could extend these and they could be two separate functions, right? Couldn't I extend this green side and make this a whole nother function that comes down right here, right? And I could do the same with red. I could extend that right here, right? And have a whole separate function. And if I did that, we could name both of these functions. So let's say I only look at the red side right now. This red side, if I wrote the equation for this, this would be y equals, what's my slope? 1. So 1x plus 5, right? Because it's got a y-intercept right here at 5. And then on the green side, doesn't this have a negative slope of 1, and it's going to cross at negative 5. So I could rewrite this as y equals negative x minus 5. So these could be two different functions, but as a piecewise function, they converge into one piecewise absolute value function. But really, these functions don't exist down here at the bottom. So I'm going to erase this because that part doesn't actually exist. I just wanted you to envision it. But where does this switch of these two functions, occur? It occurs, I just erased that for some reason. This switch occurs right here at x equals negative 5. So this is kind of where I could draw an imaginary line, and I could say that my graph switches at this point, right? Like there's a green side and a red side, and that happens at negative 5. At negative 5. So piecewise is this. Piecewise is recognizing that you have two functions and where they switch. And here's how we write them. We have a special way of writing them. We're going to say that y equals, and then we're going to write this fancy brace. And we're going to take our green side, which is negative x minus 5. And it also equals our red side, which is x plus 5. It's two parts. Y actually equals two different things. And then we're going to use this negative 5 to show when that happens. So I'm going to put commas after each part of this, and I'm going to use an inequality to tell when that happens. So the green part occurs when x is less than negative 5, and the red part occurs when x is greater than negative 5. And this right here is my piecewise function. So it's pretty crazy looking. It says y equals brace, squiggly brace, and then it lists each different equation for each piece of the function. It works really well with absolute value, but it doesn't have to be done with absolute value functions. So let's look at a different one. What if we've got something that looks a little bit similar but isn't quite the same? Let's say we've got a function. Okay, so if we had this thing, well, too bad I can't graph very well, but look at this. This kind of looks like an absolute value function, but it's not. It's not symmetrical. But what it is a piecewise function because it has two distinct parts. And if we come back here with our invisible line, you can see that there's two pieces here. There's definitely a left side that I'll put in green, and there's definitely a red side, well, that I'll put in red, that's over here on the right. And each of these is going to have their own function. So we need to figure out what the function is for the green piece and for the red piece. And to do that, we're going to count it out. So if we look at this green side, what's our slope here? First of all, we have a negative slope, and it's going down 2 over 1. So we're going to have negative 2x, and our y-intercept is 8. So negative 2x plus 8, okay? That's the green side. Let's look at the red side. This has a positive slope, and it's going rise over run. It's going up 1 over 2. So I've got a slope of 1 over 2x. Now my y-intercept I can't see, but if I keep following this trajectory, I would go something like this, and I can see that my y-intercept is going to be at negative 2. Okay, so again, this piece right here that I extended doesn't actually exist. I just drew it in to help me see this. Now, those are my two functions, but I'm not really done writing this out. Where is the function switching over? When does that happen? Well, it's happening right here on my yellowy orange line, and that's at 4. So I'm going to, on my green one, I'm going to say that the function negative 2x plus 8 exists when x is less than 4 or equal to, and the red function exists when x is greater than or equal to 4. And then I'm going to finish this off by writing y equals and putting my squiggly bracket. So that's what a piecewise function looks like. Now this has two pieces, but we can definitely have functions with 3 pieces. Let's look at what that might look like. So if we do that, we can have as many pieces as we want, and everything we're going to look at today is going to be linear, but these things can get crazy. So let's start by drawing this. Let's say we're going to have this function, and then it's going to curve and go up, and then it's going to go straight like this. So this is a piecewise function with 3 sections. All right, so these 3 sections, we're going to have, we can see we've got a green section on the left. We've got a second section right here in the middle. And then we have a blue section, that's not blue, a blue section over here on the right. So that means we're going to need to write the functions for all 3 pieces. Okay, so let's start with green. This is a negative slope, and it's going down 1 over 1, down 1 over 1. So the beginning of our function is going to be negative x. Where is this going to cross? I'm going to extend my line to see where it would cross, and it would cross over there at negative 4. Okay, let's look at pink. We have a positive slope. It's going up 1 over 1. So the slope there isn't too bad, so x. And it would cross, if we extended that, it would cross at positive 4. Okay, so x plus 4. And now what about our blue piece? This is just a flat piece and it's at 3, and this is a y value. So the equation of that line is just 3. All right, so now comes the tricky part. Now we have to figure out where each of these are happening. So let's get back out our yellow line that divides things. So we can see that there's clearly 3 sections. So the green section is happening when x is less than or equal to -4. X is less than or equal to -4. What's happening in the red section? The red section is happening only in a small spot. So it's happening when x is greater than -4, but less than -1. So write that inequality really carefully. So write down your x, and it's going to be when x is greater than -4 and when x is less than -1. Do you see how I wrote that in one big piece? And then our blue part is happening when x is greater than or equal to -1. Finish up with your y equals in your bracket. Okay? Do you see how we did that? Not too bad. Now, everything we've just drawn all connect together, which is great, but that doesn't always happen. So we're allowed to have piecewise functions when they don't all connect. And that would look something like this. We might have this happening right here, and that's followed by this, and then maybe it zigzags back up. So in this function, we would follow the same steps, but we would recognize that the green doesn't necessarily touch the red or the blue. So this is discontinuous. It's discontinuous. Whoops, let me write that. It's discontinuous, which is fine. That's allowed. It's still a piecewise function. And we would keep writing it the same way. The only difference is this yellow part right here, our invisible line happens right here at -5. Well, when we went to write this, we would say y equals, and our green part is going to be y equals 1. And that happens when x is less than -5. And you would have to look really closely. If there's a closed dot, then it would be less than or equal to -5, right? On the next piece, on our red section, if there's an open dot, we would say that in our red section, let's see, that's got a negative slope, it's going down. It looks like it would cross at -1. So y equals -x minus 1, and that's happening when x is greater than -5. And I'm not going to put the equal to part right there because this open dot means it's not equal to, right? Open and closed dot. And then we would finish that by saying or less than -2. And then we would look at our blue piece, and our blue piece is continuous. It has a positive slope going up, and it's crossing at 3, so x plus 3. And that's happening when x is greater than or equal to -2. And that's because, oops, this was equal then. And that's because it's continuous. So it's continuous right here where it connects, and this is discontinuous right here where it did not connect. Totally allowed. Okay, now the last thing we're going to see in this will be if you're just given a function. So what if I tell you that y equals -2x plus 3, y equals 5, and y equals 1/3 x minus 2. And let's say this happens when x is less than -1, and y equals 5 when x is greater than -1 and less than 1, or equals 2. And 1/3 x happens when x is greater than 1. So we're going to graph this and we're going to see what this looks like. And these graphs, they get wild and it's totally okay. We're not going to worry about it. The first thing I like to do is I'm going to come over here and I'm going to look at where my important invisible lines are. So -1's a hot spot. Oops, I lost my 1. There's a 1 right here. And 1 is a hot spot, right? So these seem to kind of be important points. So I'm going to go ahead and I'm going to come draw myself some lines at -1 and 1. Okay, they're just invisible lines, but I know that things are going to change. So let's start with our first one. We've got -2x plus 3. I'm just going to graph this line as per usual. So 2x plus 3, but I'm going to draw it like maybe with dots so I can go and erase it. So this is going to be my red one. Red. So I'm going to go here to 3, and a slope of -2 means rise over run. So up 2 over 1, it's coming down. So up 2 over 1, up 2 over 1, up 2 over 1. Okay, so remember, it only is happening when x is less than -1. So I'm only going to connect these right here. I'm not gonna keep going past my yellow line. And it says or equal to, so I'm going to make sure I make that a solid line. Okay, my blue part's going to be next, and that's just y equals 5. So when y equals 5, I'm just going to draw a straight line right here, because that's just horizontal, right? And that happens in between -1 and 1. So I'm only going to draw that for a little portion. The next piece is going to be green, 1/3 x minus 2. So minus 2 is way down here. I'm going to put a little dot there. It's positive slope, so I'm going to go up 1 over 3, up 1 over 3. But that's only occurring when x is greater than 1. So when I go to connect these lines, I'm only going to connect them out here. And it says, oh, it doesn't give me a or equal to, so this is going to be an open dot. My blue ones were equal to. So those are going to be closed. So that's how you draw these things. You just literally take them piece by piece. Draw yourself invisible lines. Please, please remember that these yellow lines I keep drawing are not actually there. They're just drawing myself little walls. So you go piece by piece. You start graphing them as per usual, but you really only fill them in their certain little section. They all go together. They do not have to be continuous. You can have a discontinuous graph where it jumps, totally allowed. You use inequalities to show the different intervals or areas that the graph exists. So every piecewise function is y equals squiggly bracket, and then you list each function followed by the place where it exists. Should we do one more? Okay, let's do one more. And let's say we've got something that really won't make our heads hurt too much. Okay, let's say we've got y equals squiggly bracket 2x -1 and x plus 3. 2x exists when x is greater than 3. -1 exists between -2 and 3. Remember, watch your inequalities. And then x plus 3 exists when x is less than -2. Okay? So First things first, I'm going to go find my important numbers where my barriers are. It seems to be at 3, and it seems to be at -2. So I'm going to go draw myself barriers. I'm going to go top to bottom because I don't really know where this graph's going to be. All right, so let's start with our top one, 2x. I'm going to draw that in red. So that has a y-intercept of 0, and it's going to go up 2 over 1, up, and I'm going to kind of up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then I'm going to connect it only when x is greater than 3. And then this says that it's not equal to, so I'm going to make sure I put an open dot here. Okay, our -1 is horizontal. I'm going to use blue for this, and it's going to be in the center section. So -1, I'm going to come down here, I'm going to draw a horizontal line, and it's got greater than or equal to. So that means it's going to get closed dots. And then my final one is x plus 3, and that's occurring when x is less than 2, so over on my left side. So x is less than -2. Oh, and my function is x plus 3. So my y-intercept would be at 3. And then it's plus 1, so up 1 over 1. So I need a positive slope, so uphill. And then I'm only going to connect my lines on this left side of the graph. It also is going to get an open dot because it does not say or equal to. So my final answer looks like this. And if I'm really on top of things, I'm going to go back and I'm going to erase all the chicken scratch I made to help me get set up, right? And so truly, this is your final graph. So here's what your final piecewise graph looks like. And that's it. This is such a useful skill. And it's really looks super fancy and complicated, but it's really basic if you just break it into pieces. Good job.